Okay, so let's start part 1 of complex numbers. So, what is an imaginary number? You might have heard me talk about it, and I said it's coming, but now it's here, so let's actually do some problems with them. So, an imaginary number is a number that is expressed in terms of a square root of a negative number. Okay, so you'll see this a lot. So whenever you take the square root of a negative number like -1, so up until this point you say I can't take the square root of a negative, which is true. You can't get a real number. So all the numbers that you've talked about, I'm trying to do a good job of explaining what this is. So you have real numbers, which are the fractions, decimals, whole numbers, all that stuff, positive and negative, right? So those are rational numbers. And then you have irrational numbers, which are like, you don't need to write this down, just listen, like pi, right? It goes on forever. You can never like write it as something nice and neat unless you use the pi symbol. Square root of 2 would be an irrational number. It's the square root of 17. It's something that you cannot put in a calculator, and it will not give you either a fraction answer or a decimal that you don't have to round. Okay, so all of those are real numbers. That's all the numbers that you've ever dealt with in your math career. Now, a separate thing is called an imaginary number. Okay, it's not a fake number. They just call them imaginary numbers. And so imaginaries are anytime you take the square root of a negative number. Okay, so back to this. The square root of -1. So anytime you take the square root of -1, this is I. Yes, I know it's weird. You write it with a little tail on the end. And so anytime you just know that the square root of I, or square root of negatives, is I. Okay, so let's do a couple. And so let's simplify the following using the fact that the square root of -1 equals I. Okay, so let's go ahead and do this. So what's the square root of -4? So we know there's a negative in there, so it's going to be something I. And then what is the square root of 4? Well, that's just 2. So this answer is 2I. Weird, I know. Okay, what do you think the square root of -25 will be? Well, it would be 5I. That's it. Square root of -18. Well, this is not a perfect square, but I can break it up. So of course you need to break it up when you can. So let's talk about how you break this one up. So which perfect square goes evenly into 18? Well, 9 does. And so since at 9 and 2, right? And I need one of them to be negative, and I'm going to put that on the 9, and you'll see why. So then when you take the square root of both sides, right, because that's what that is, -9 times 2 is -18. That would be 3I square roots of 2. Let's write a little note. Never leave negative under the square root. Always pull it out and make it an I. Okay, same thing with this one. If you want, pause the video and try it by yourself. 32 is not a perfect square, so it breaks up into, I'm going to do the easier one. You might say 4, and that's true, but you'd have to do it twice, but 16 works better. So -16 and 2. So this would be 4I square root of 2. Also, Notice whenever you're doing this, you always write the whole number out front, then you write the I, and then you write the square root of 2. Okay, and then this last one, square root of negative 10. You can't do anything with 10, right? 4 doesn't go into it, 9 doesn't go into it. So this would just be I, because we can't leave a negative under the square root. Actually, I'm going to write it like this. Maybe it'll make sense a little bit more. I'm going to break this up as negative 1 square root of 10. We know that turns into I, so this would be I square roots of 10, or I times the square root of 10, however you want to say it. And that is in simplified form. Okay, so this next part, they're going to add a little bit to it. So simplify the following expressions using the fact that, okay, this comes up a lot. It's huge, so make sure you write this down. Anytime you have I times I, that equals negative 1. So let me prove to you why that works, just because I care and I want to. So if you have the square root of 4 times the square root of 4, right, that's the square root of 16, which is just 4, right? So let's do it again. Square root of 3 times the square root of 3 equals the square root of 9, which is just 3. Right? So anytime you multiply the same square root by itself, that number is what you're going to get, right? But you just take the square root off of it. Okay, so the same goes for the square root of negative 1 times the square root of negative 1. That equals the square root of 1. Actually, I'm not even going to do that because that's going to be confusing. So this would give you negative 1. Right, because of those same exact ways. But now let me take these, because we know the square root of negative 1 is I, so this is really like I times I. That's going to give you negative 1. Another way to write it, let's write it over here. If you have I to the second power, which is the same thing as I times I, that's negative 1 as well. So just remember, I times I, not plus. I times I gives you negative 1. Okay, here we go. So now they want us to add these. So adding is the easiest way to do this, right? These parentheses are not doing anything, right? There's no number out front of the parentheses that we need to distribute. There's just a plus sign, which doesn't change anything. So really, the parentheses are not doing anything for this. So you just combine like terms. So I have 4 plus 2, that's going to give me 6. And then positive 2i plus negative 6i would give me negative 4i. You treat it just like a variable. And this is your answer. Notice you always write the real number first and then the imaginary number second. Kind of like whenever we did that with square roots. Okay, this one's a little bit different. So since they're being subtracted, actually the second set of parentheses are doing something on this. So you have to distribute that negative. So this would give you negative times negative 3 is positive 3. Negative times positive I would give you negative I. And then I'm just going to drop down this other stuff. Okay, now we're just ready to combine your like terms. So negative 9 plus 3 would give me negative 6. Positive 5i minus I would give me positive 4i. And you cannot combine real and imaginaries, so that's it. Okay, try these next, or just do this next one. If you want to pause it, pause it. Try it on your own. But let's go ahead and distribute that negative first, of course. So this would be negative 1, and that would turn into positive 2i. I'm going to drop everything else down. I don't need those parentheses because they're not doing anything. Combine your like terms. So this would be 11, and then negative 3i plus 2i would give you negative I. or if you wanted to write -1i, that's perfectly fine too. Okay, so now what's happening? So now they are being multiplied. You have two binomials, or two complex numbers is really what it is. It's called a complex number. Two complex numbers being multiplied. They have two terms, so we are going to have to distribute twice. Or if you like the gross word FOIL, I don't. But if you like FOIL, say FOIL. So you're going to have to do 4 times 2, which would give me 8. 4 times -6i would give me -24i. Okay, and then you need to distribute the second term, which is +2i. So +2i times +2 would be +4i. +2i times -6i would give you -12i to the second power. Because remember, I times I is I squared. Okay, so there's a few different ways to look at it, but remember we talked about up here that I squared is the same thing as -1. Okay, so this is the same thing as -1. So this is like -12 times -1, which makes it what? +12. Okay, and then I'm just going to bring everything else down. And let's go ahead and combine our like terms. So 8 plus 12 would give me 20. Always write your real numbers first. -24i plus 4i would give me -20i. Okay, so let's write another little note. Don't leave I to the second power in your answer. Okay, so it always needs to be turned into -1. All right, next 2. So let's go ahead and you're multiplying these. So we're going to distribute. -9 times -3 is +27. -9 times I gives you -9i. Then distribute the +5i. 5i times -3 would be -15i. 5i times I would give you +5i to the second power. Okay, so remember what we said. I to the second power is the same thing as -1. So now +5 times -1 becomes -5, right? The I goes away. Bring everything else down. Combine your like terms. So 27 minus 5 is 22. -9i minus 15i would give you -24i. That's it. Last one. Pause it, try it on your own. Let's see if we get the same answer. Okay, distribute. That would give you 12 minus 24i. Distribute the -3i. Don't forget the negative. -3i times 1 is -3i. -3i times -2i would give you +6i to the second power. But, as you remember, I to the second power turns into -1, which makes this +6 times -1, which is -6. Drop everything else down. Combine your like terms. So that would be 6 minus 27i. All right, that is it. Thanks for watching. Have a great rest of your day.